name is Dr. Darrell Boyd, the chemist, and I'm coming to you on behalf of the Transformational Education Adventure Center, also
Dr.
known as
Boyd,
the...
you might have to start again. Okay, now start. Start.
Okay.
Go.
Good evening. My name is Dr. Darrell Boyd, the chemist, and I'm coming to you on behalf of the Transformational Education Adventure Center, also known as the T Center, which is located in McLean, Virginia. And I will be teaching tonight a STEM lesson. Here's what you'll need if you want to follow along. Baking soda, vinegar, a container like a plastic bottle or a glass bottle like the one I have here, make sure it's empty and clean, and a balloon. All right. Today we're going to learn a lesson about the 3 common states of matter. The 3 common states of matter are solids, liquids, and gases. And we often come in contact with each state of matter all day long. One of the best examples is, think of water. Water is a liquid, but water has the same molecular makeup as ice and water vapor. That makeup is H2O, also known as 2 hydrogens with 1 oxygen. In the liquid state, it's water. In its solid state, it is ice. In its gas state, it's water vapor. So if you take a pot of water and begin to boil it on your stove at a certain temperature, 100 degrees Celsius, it will begin to evaporate away as a gas known as water vapor. If you take that same water and freeze it down, it will turn into a solid at a specific temperature, 0 degrees Celsius. That solid will be ice. And so those are the 3 common states of matter, and you can see them on a daily basis. Water is perhaps the best example that we can think of. So what we're going to do today is we're going to find out if we can trap gas. Why is that a difficult thing to think about? Well, unlike a solid and water, gas just spreads out into whatever space is available to it. The difference between a solid and a liquid is a solid it has a defined shape, So if I take my marker here and I put it in on this tabletop, it stays the shape that it started with. A liquid, if I take a liquid and were to pour it on this tabletop, it will keep running until it meets some kind of barrier. If I pour it into a cup, it will take the shape of that cup, all right? So a liquid takes the shape of its container, but a gas just spreads out into whatever space is available to it. So we're gonna try to find out if we can trap gas. Here's how we'll do that. I'm going to take my empty container. I'm going to pour some vinegar into my empty container. Separately, I'm going to take this balloon, and I have here a funnel. If you don't have a funnel, you might take a piece of paper, fold it in half, and then pour your baking soda into that folded piece of paper, and then use that to pour your baking soda into this balloon. But I'm going to take my funnel, and I'm going to pour the baking soda into this balloon using the funnel. All right. If you want exact measurements, I would say use no more than 4 tablespoons of baking soda and no more than a half cup of vinegar. All right. I am just going to eyeball it today. So I have my baking soda. It's in my balloon here. I'm going to add a little more. All right. Now I'm going to take my vinegar. And again, I'm not measuring this out, but if you are, I would say no more than a half cup of vinegar for a container that is about 16 to 20 ounces. Also, if you want to have real fun with this, you can take some food coloring and mix it in with your vinegar just to give you a little color. But now I'm going to take my balloon and I'm going to carefully cover the mouth of this container. I don't want to tip the baking soda out of it just yet. So I'm going to take the balloon and bring it over the mouth of my container here. All right. Now, if you're doing this at home with me, I want you to make a prediction. What do you think is going to happen? I have inside here baking soda, and I have inside here vinegar. What do you think will happen once I tip this balloon over and release all the baking soda into the vinegar? All right, let's give it a try. Check it out. Oh, still growing. Okay. Notice that the balloon has now filled up with something. What is that something? It is filling up with gas, and not just any gas. It's specifically filling up with carbon dioxide gas. Why? Well, baking soda, which was inside the balloon, is actually known as sodium bicarbonate. The vinegar is a diluted form of acetic acid. Well, when acetic acid and sodium bicarbonate get together, they form carbonic acid. Carbonic acid spontaneously breaks up into two compounds. One is water, the other is carbon dioxide. We know water is a liquid, and so it will stay at the bottom of the container. We also know that carbon dioxide is a gas, or it can be a gas. So in this case, it is a gas. And it fills the space that is available to it. When there was no more space available to it on the inside of the bottom, it went into the balloon. And because the balloon is flexible, it caused the balloon to expand and kept on expanding until there was no more carbon dioxide to fill it up. All right. So we have now looked at a gas taking up as much space as was available to it. And that's what gases do. In this case, I could have left the lid off of the container, but if I had done that, then the carbon dioxide would just gone into the atmosphere all in the area surrounding the bottle. But because I had the balloon on the mouth of the container, I was able to trap it. And so now I have carbon dioxide trapped on the inside of my balloon. All right, so before we go, let's briefly review. What are the three common states of matter? All right, they're solids, liquids, and gases. What is a good example of all three states of matter that we encounter on a common basis? All right, H2O. H2O, as a solid, we call that ice. As a liquid, we call that water. And as a gas, we call it water vapor. All right, but they're all H2O, or two hydrogens combined with one oxygen. Okay, very common example, and we can see all three states of matter just by changing the temperature. You change the temperature, make it really, really cold, below 0 degrees Celsius. We have a solid. We have a liquid if it's between 0 and 100 degrees Celsius. And we have a gas if it's greater than 100 degrees Celsius. All right, that is our STEM lesson for today. I hope you enjoyed it, and I will see you next time.